Hi, everyone. Thank you so much for taking time to watch this session. This session is really focused on working with data in your products. My name is Thomas Fair, and I'm joined here with Max Payson. Really, the purpose of this session is to provide tips and tricks for working with user data across multiple tenants. Few disclaimers here. The focus will be on primarily vector data and feature services. They're the most common that you would build with and integrate with, and also high-level workflows. But make sure you check out other sessions to dive in. There's lots of opportunities with other sessions that are available from this developer summit, where you can really dive into these specific areas. And of course, at developers.arcgis.com, there's tons of sample code resources for you to take advantage of. High-level agenda, kind of going to go through an overview of different layer types that exist in the ArcGIS platform and value for using each one of those. Also talk about creating services, provisioning services, and how you can access services. So let's take a look first here at an overview of data in ArcGIS. So ArcGIS helps you store, manage, and integrate all types of data. And we support imagery, tabular, unstructured data, vector-based content, tons of advancements in 3D content and layers. Of course, real-time data. And real-time data, you can think of it as land, air, and sea assets that are moving, but also sensor data and all different velocities of data that we can ingest when it comes to real-time. Big data, and here this is big data, and being able to process those and extract and do analysis against this big data. Of course, LiDAR and some of our advanced tooling that we have there, and leveraging a large part of these new BIM models, bringing that in. All of this gets brought in and integrated and is presented through web services. And you can present this content and view it in maps or 3D scenes and integrate with different layer types. Putting a little bit of a table in front of you, I thought this was a really valuable view of different layer types that we have, the REST API service that you access for that layer type, looking how it's hosted, if it's available with ArcGIS Online or Enterprise, and if it's available to be cached. ArcGIS Online is, as you know, our SaaS hosted platform, and ArcGIS Enterprise enables you to deploy the ArcGIS platform on premise or in a private or public cloud. It's really a managed infrastructure. As you can see at a high level, ArcGIS Enterprise does offer some additional layer types that aren't supported today in ArcGIS Online. But of course, you still have the powerful services that you can leverage in online. This is also really helpful if you're planning for your different data types and how you want to represent data in your application. And if you look at these different layer types, there's different kind of functionalities that are available. There's also performance considerations. So you can be creative in how you present certain data based upon certain scenarios within your application. And so, yeah. Taking a look first at the tile layer. So this helps you display base maps and other complex data sets that change infrequently. Think of city and county or state boundary data. It's not changing very often, right? And this then is represented as images. Tiles can be kept in sync with feature layers, so you can have it so that the tiles are updated when your feature layer data is updated. Next is the vector tile layer. So you can display base maps and other complex data sets that change infrequently, but this is represented as vectors. And There's various ways for you to create these vector-based maps and advantages of using the vector tile layer. Next is the dynamic map layer. So this helps you display complex data sets that change frequently or need complex rendering requirements. They are represented as images. So you could have a geodatabase with transactional data that you're editing frequently. And what happens is our server technology actually, when your application makes a request, our server technology creates that image dynamically against that database and then sends that to your client. There's also the image layer. So you can render, analyze, and dynamically interact with imagery data. And this is represented as images, but we have APIs and different tools to enable you to interact with image layers to not just display imagery, which is obviously important, but also to be able to do analysis and dynamically interact with it. So the image layer service actually enables you to do much more than just simple display of imagery. The scene layer enables you to display and render 3D data sets, and it's represented by the I3S specification. The feature layer, which is really going to be the focus for the later part of this presentation with Max, enables you to query, render, and edit vector geographic information. It's represented as JSON. So the feature layer sends that JSON to the client, and you render that. It enables you to, again, within desktop, web, or mobile client, do editing against the data that is then sent back to the feature layer service and then into your database. There's so many advanced visualization capabilities that you have that you can do, querying. It's a very advanced layer type for you to take advantage of. With layers, many times in all applications, really in all organizations, they have tens, hundreds, or thousands of layers. And with layers, you want to bring them together and create a map. And so we do that through, in the 2D side, through web maps. Web maps are 2D maps that you can create, style, and share between apps. So think of these as really a configuration, right? They're represented by a JSON object and defined by a web map specification that we've defined. And it contains configuration settings for the map extent, layers, styles, and pop-ups. For those of you who have developed previously with our Flex Viewer or Silverlight Viewer, if you recall, you used to manage a lot of configuration within your application for what layers are in the map, what order they draw, what the pop-ups are, what your bookmarks are, what the layers look like, which ones are turned on and off, what the extent is. Used to kind of manage all these configurations, and now all that configuration is stored within the web map. And what that enables your applications to do is to be able to take this configuration across all Esri applications and all developer applications. So you can open up an Esri app, you can open up your application, map's going to look the same across those experiences. And this enables also organizations to have authoritative web maps for how layers should be represented, how they should be brought together. And it's a very powerful thing inside the ArcGIS platform. Similarly, we have web scenes, just like our 2D, but it's for 3D data. So this enables you to have a web scene for urban and natural environments and represent your building data. It's represented by JSON objects defined by a web scene specification. So we have a web scene specification that you can understand and see what you can components you can take advantage of. And it contains configuration settings for the camera height, angle, layers, and styles. Everything that you could use, again, storing that configuration into maybe a 3D scene experience that you have in your application you're developing. So these items within the ArcGIS platform, you have layers that are then collected into maps and scenes that are then represented in applications. And for interacting and managing all of these items, we of course have object storage, and there's different services and tools for you to take advantage of. Around these items, we have a security model. We have, of course, the user. Users can, with the user's identity, you can control access to what items they have access to within the platform. Each user has roles and permissions that are assigned to them. So certain users maybe can only view items. Maybe they can edit features, or maybe they can actually edit items, right? There's all different types of privileges and roles that you can assign to these users to control what they can do in your application, and ultimately what they're doing with these items. We have a concept of groups within this security model, and groups really enable you to have a collection of items within a group context, and then you can add users into those groups, and only those users within the groups maybe can only view those items, or maybe they can interact or change or update those items. So the group is a very powerful capability for managing what users have access to. And within those groups, you share the items into them, and you can share items publicly, so there's no authentication needed. You can share it at the organizational level, so anybody authenticated with an organization can see that shared item. You can share items within groups, and then you can also keep them completely private. So the security model is very powerful and something for you to really understand when designing your application and how you're planning to develop it for the different user personas and workflows that you're planning to support. When it comes to authoring, we have a variety of capabilities. We of course have our ArcGIS Pro desktop product, where you can go in, load data, and author those web maps and layers and scenes to ArcGIS Online and ArcGIS Enterprise. Additionally, we have the ability to utilize Python or Python notebooks to author and publish content. We also have tools natively within ArcGIS Enterprise and ArcGIS Online to publish items and layers and maps and scenes. So there is a variety of tools and capabilities for you to take advantage of. Next, I'm going to hand things over to Max Payson, who's going to walk you through creating services. The focus here for creating services is really going to be around that feature layer service. And as he walks you through some additional information as well as some demonstrations. So with that, I'll hand it over to you, Max.
Thanks, Thomas. Hey, everyone. So I'm going to spend a little bit of time talking about creating, sharing, and then discovering services. So to start with creating services, let's talk about some common challenges that partners and developers often face when they're building products. One is working with many user-owned data sets. So each user needs their own layers, they need their own services. And then the second challenge is that those items and layers should all have a consistent experience. So now you have this situation where you have many layers and you need to configure each of those layers so that they're consistent across all your users, and that can be very difficult to scale and automate. So we come across this a lot in working with partners and developers, and we're hoping to give just some quick tips and tricks in this context. So generally, our suggested workflow is to first author template services through the ArcGIS UI. That can be Pro, that can be ArcGIS Online or ArcGIS Enterprise. And when we say template in quotes, it's really just any other ArcGIS item, but you're then able to, once it's created, access its properties and copy it into new services that you create so that they behave and act and look the same way. So then second step, create those new services, and third step, copy the template properties. Before getting too far along on the slides, let's take a look at a quick demo. If you're familiar with ArcGIS Online, this is going to be very straightforward, but basically we're just going to create one of these template items in ArcGIS Online. So let's pause the show and switch over. So here I am logged into ArcGIS Online with mpayson_startups, and we can see EPC demos from some of the other sessions. So let's first create an item, and here we have some sample data of New York City restaurant inspections from the Open Data Portal. One is a CSV and one is a GeoJSON. Let's drop in the CSV. And what this is going to do is it's going to process the CSV, detect the fields, and then send that into a feature service. So here, NYC restaurant inspections. Let's add some tags like EPC 2020, demo, excitement. And then let's also publish the CSV as a hosted layer. We can see that what ArcGIS Online is doing is it's automatically parsing the field information. It's detecting, for example, that the X and Y are the longitude and latitude, and then we can add that as an item. So this takes the CSV data, it's going to pipe it into a database, and then from that database expose a feature service and a feature layer hosted in ArcGIS Online that you can then interact with to Thomas's descriptions earlier. So this is creating, let's add a summary, my very descriptive summary, and then a description. Cool. So what I'm doing here is I'm just adding basically metadata for my items. And the reason I'm doing this is that in a lot of cases, your users may be accessing the ArcGIS Online items directly from your application, in which case they won't interface with this page. But if they do, or if you want to present some metadata about that item in your UI, such as a description, this is where that can get maintained authoritatively within ArcGIS. There's also a section on adding terms of use. In this case, it's demo, so we won't put any. And now we have some very descriptive, very detailed and thorough metadata about this New York City restaurant inspections layer. Quickly, before configuring the visualization, here we can just see the underlying data that was included from the CSV. And now let's start configuring this inspections layer to have a UI that we like. So these orange dots could be improved. So let's instead symbolize this by the grade of the restaurant inspection. We'll use single types. A is generally good, so we'll make that green. B is okay as blue. C, we'll make it orange. Z, that sounds terrifying, so we'll make it red. And then P seems kind of indifferent, so we'll make it purple. Okay, so now we have a simple map. Excuse the cartography. It's not as beautiful as it could be, but we'll leave it for now. And then we can also apply some additional settings. So let's enable clustering so that the locations are a bit more clear. And since we don't want everything to be green, we'll downplay the clustering so we can see some of the other inspection locations as well. One more thing that we can do is we can configure the pop-up. So we'll keep the pop-up title as NYC Restaurant Inspections, and then change the attributes to only display, in this case, let's do street, the inspection date, and the grade. Click OK, and now we can save the layer. So what we've done relatively quickly here is we've created a rough template of how we would want this layer to look in our applications. We have a renderer, we have some clustering, we have some pop-ups, and then we also have some metadata on the overview page. Okay. Let's talk a little bit about what's happening here behind the scenes. So there are a couple areas where these properties that we just set get stored. One is in the item properties itself. So this contains that description we wrote, the tags when we initially create the item, the license information, and more. And this is stored, the REST API is in the base content URL /item/item ID. For all the ensuing pictures, you'll see the REST API endpoint underneath them, so it might be a helpful reference in the future. The second area where the properties get stored is in the item data. So not in the item itself, but actually in the /data endpoint. In this case, it's just a JSON representation of additional properties. So does that layer contain pop-ups? How are those configured? Is clustering set on the layer or filters applied, etc.? And then on the service properties, we have a whole lot more visible range, what editing can be done on the service. These service properties are actually really powerful, and they communicate or basically determine the majority of the operations of how the service and the layer behaves, and allow you to control that. So there's a whole lot here to unpack. I would say, unfortunately, it's not as well documented as it could be, but I'll get into that a little bit more later. One specifically that I want to talk about is editing properties. We give pretty good fine-grained editing control when you want to interact with these services in your app dynamically. ArcGIS does a lot of really cool stuff when it comes to transactional editing in a database and then distributing that data into maps and applications, especially at scale. So for editing properties, you can control what kind of editing is allowed. Can you add or update, delete features, just add features, etc. You can also add different permissions and tracking, so can editors view data or can they only add data? And then the permissions of who can actually take advantage of these settings depends on who the layer ends up being shared with. So if a user has access to the item and that user has a license that allows them to edit data, then they'll be able to edit the data based on the settings that are configured on the service. And again, this is all done at the definition level of the feature server. As a quick, somewhat tangent, earlier Thomas mentioned that there are map and app properties in addition to just layers, and I thought it'd be helpful to mention how those get represented as well. So in this case, the item properties are similar. You have your description, your tags, and your license, but basically everything that represents a map and an application, a configurable application and online, is stored in the item data endpoint. So for a web map, when Thomas showed that JSON spec, that's stored in the item data. Same thing for the web scene. And then for configurable apps like dashboards, the theme and configuration of that dashboard is actually stored in item data as well. So these properties are there, and they're kind of interesting to explore and understand and helpful when you want to replicate behaviors across maps and apps. Okay, so now let's talk about how this actually works programmatically so that you don't have to set everything up ahead of time. You could programmatically onboard a user, for example, by creating services for them. So the way it works is, first you can fetch the item information from the template. That returns a bunch of JSON objects, as you saw earlier in those screenshots. And then next step is to create a new service. And you can do that in two ways. One is you actually just create an empty service. And then the other is you publish a data file. So you upload a file into ArcGIS Online and then call publish on that file to turn it into a service. That's what I did when I was uploading that CSV. I added the CSV to ArcGIS Online and then called publish, and now it's available as this nicely configured service through the GUI. You can do the same thing through the REST APIs. Then the next step is to start copying in the properties from the item information. So this is where you're updating the item to represent the description, for example, or you're updating the definition to describe the visible extent. So you're taking advantage of that data that you pulled down in step 1 and passing it through in step 3. One really important note here that I alluded to earlier is that these services, and especially the schema that's stored in these services and that you use to define the properties, is not documented. So understanding how to use that can be a little difficult. So my strong recommendation would be to use a Esri written wrapper to perform these operations. One could be the Python API, which is what all of our demos will be. Another could be an up-and-coming Solution.js library, which is open sourced on GitHub for cloning items with JavaScript and Node. And then there might be other wrappers as well. If you have to use the raw REST APIs, you can. My guidance there would be to first perform the operation in online, monitor the network traffic that shows the request that online is making through the GUI, and then replicate that network traffic in your code so it can be automated and scaled. It's a little bit of a kludgy workflow, but it can work really well, and you can accomplish some really amazing automated tasks. And it's also surprisingly powerful, the things that you can control. You can reset an index, for example, or create a new index on the feature service to improve performance for specific queries. So there's a lot there, and there's a lot there that you can explore. But again, my recommendation would be to use Esri written wrappers. Okay. One last note that I think is good to communicate is for feature layer views. So you don't always have to create a new service like I described in step 2 before. Instead, what you can do is you can create what's called a feature layer view, which is a new item in online that references a primary authoritative layer and has separately configured settings and permissions than that primary layer. So this means that you can publish one layer and then create different views for different personas within your application without having to worry about maintaining separate services and separate databases. Everything can just reference the same authoritative database. This can be very powerful, and it's also a good way to create subsets of data. So let's say that you have a maintenance request layer. You want to make a public version of that layer where people can submit maintenance requests but not see existing ones. And then you have another version where you want an administrator to be able to see all the maintenance requests. And then you have a worker that you only want to be able to see the maintenance requests that are assigned to them. You can use views to set that up and have everyone working against the same database, but have those interactions controlled by the settings defined by the view. Okay, so I would say that's probably enough slides for now. Let's get into a couple more demos to try and make this a bit more tangible. So these demos are all written with the Python API, and they're running in Jupyter Notebooks, but you can run them anywhere that Python 3 is supported. So first thing I'd like to do is connect to my GIS where my layer template lives, and then we're going to explore this layer template a little bit. So we'll grab the item ID, copy that item ID in, and then fetch the item level properties, the item data level properties, and the service level properties. And we can explore what these look like. So T item props, for example, we can see contains my very descriptive description, as well as the title of the layer and additional metadata. T item data props, this is at that /data endpoint, contains the pop-up info. So we can see, for example, that the majority of the fields, their visibility is set to false, but if we go down to street, that visibility is set to true, which is what we configured in the UI. And then at the service level, we see basically all the capabilities that are supported by the service. Is the data versioned? Does it support advanced queries? What advanced queries does it support? These are all relatively fine-grained controls that determine how the service interacts and behaves. So let's hide the stuff for now and move on to creating some services. First service that we're going to create is an empty service. So here I'm using the clone items function in the Python API. It's very powerful. It basically abstracts all those arrows I was showing you earlier into one call. And So what it's going to do is it's going to clone this template item. It's going to not copy the data, so it creates an empty service. And then if there's already an existing clone, it's going to ignore it. And then we're going to update the item title so that we know that this is the clone and that it's called empty EPC 2020 demo inspections. We'll give this a quick second to run. And again, in the background, this is making those calls to first fetch the properties of the original template item and then copy those into a new service. We can see it's created here. We'll check it out online in a second. Another option is we can create a service with a new data set. So this is very similar. It's creating that empty service, but now we're taking a GeoJSON file and reading that in, editing the features in the service so that there's data in it, and then updating the title again. So the reason that we're doing that is that maybe instead of having an empty service, you want to be able to share a data service with your users that's already pre-populated with some data. Again, we'll give this a hot second to run. Maybe a hot second and a half. Okay, cool, it's done. So let's check out what we got. So we go back to content. We now see that we have the empty EPC 2020 demos feature layer, new EPC 2020 demos feature layer, and the new 2020 demos, if we look at the information, we see that my descriptive summary was copied over, all this metadata was copied over, the tags were copied over, even the excitement tag, so it's all there. And similarly, we can see the data that was populated from the GeoJSON file. Now, if we check out the empty demo inspection, we'll see the exact same, but now with no data because it's an empty service. Cool. Let's go back and show one more way to create a new item. So here, instead of creating a whole new feature service with a whole new database, instead what we're going to do is we're just going to create a view from the service with the GeoJSON that already exists. So we'll start running this, but basically the way it works is it creates a view on the on that layer item that we just created. It moves it into the EPC demos folder, and then we define the visible data, in this case with a SQL where clause. So this means that someone accessing the view will only be able to see restaurant inspections that are in Manhattan and not other restaurant inspections. Then we grab a couple properties that we're interested in and query the extent of the view so that the so ArcGIS Online knows where to open the map. In this case, we're requerying it because the extent of the visible data will only be over Manhattan, not over the entire city of New York. So it makes sense to requery the data and reset that on the service. And then finally, we send it up to the view item to update the properties. So let's check out what this looks like. Here we have the view, and here we have the same descriptive summaries. And if we go check out the visualization tab, we see that it remains consistent, but now we can only see the data that exists over Manhattan. Okay, that's an overview of creating services. Let's now move on just to a couple quick tips on updating data. So for feature services in particular, there are 3 approaches that you'll see reflected through the UI and API calls to update data. One is apply edits, and this sends individual JSON features to a endpoint and is really meant for transactional edits. So it inserts the feature one at a time into the database, for example. So if you have a user in the field that's updating the status of a maintenance request, then this apply edits is a really good method for that. Another option is to overwrite the entire feature set. And this is good for ETLing a full data set. So if you're piping out GeoJSON, for example, from your system, and you want to distribute that through ArcGIS Online hosted feature services, then you can use overwrite to just clear out the feature service and add in the new GeoJSON. Similarly, in online, there's a append function that is really useful if you don't want to overwrite the entire service. So if you want to add new data onto an existing service from a GeoJSON file, or you want to upsert, so replace some of the features that exist with new ones from the GeoJSON file, again without overwriting everything, then append is really useful. When it comes to updating the schema and other behaviors of the layer, update definition is your friend. This is how you can add fields, set domains on those fields, control editing, that kind of stuff. So update definition endpoint, very powerful. But again, to figure out how it works, either use a ArcGIS client like the Python API, or monitor the traffic that ArcGIS Online makes from the UI. And then the last one is to update item properties. Generally, I would recommend editing the template item first in the UI so that all the changes are made appropriately, and then copying whatever is outputted and saved into that item template into the services they've already distributed. Cool. Moving right along, let's now talk about provisioning services. So you've created your services, how do you get them to your users? So a couple common challenges come up in this scope. One, how do I give my users access to data, right? Kind of makes sense. And then there are also generally some questions that are important. You need to understand who administers the services once they have access, who pays for the services, where does the data actually live? These are all important concerns when you're giving access to the data sets, and there are pros and cons to the different approaches. So those three approaches there are three of them. One is to register a service in the user's GIS. Another is to share a service via a group in ArcGIS Online. And then the third is to publish the data directly to the user's GIS. Just to quickly talk through the mechanics of these. So when you register a service, basically you have your data in your infrastructure. It could be online or enterprise. In this case, we're showing the diagram for an image server. And actually, that's an important point. So when I was talking about creating services, to Thomas's note earlier, the focus was very much on feature services, right? Because it's really common, and we thought that would be the one to kind of double click on and go in depth. But now that we're talking about provisioning services, this actually can apply to any type of service or layer within ArcGIS. So when it comes to registering services, you have that data in your infrastructure, and basically you create credentials for the user in your instance, give those credentials to the user, and then they reference the service, enter the credentials, and that service gets embedded within online or enterprise. Or sorry, it doesn't get embedded, but online or enterprise then acts as a proxy to that service. So when a user requests it, they have access to this. They have access to the data and the credentials. So the user requests your layer, it grabs the credentials that you gave them, and then forwards the request onto your server. So in this case, the developer controls the administration and pays for the service because it's living within your environment. And the other important note is that it works with any service, right? This can be online or enterprise where the data lives. So yeah, you can have an image server, you can have a real-time streaming server, and you can have a feature service as well. Oh, sorry. One other important note here is if you're using this pattern in commercial products, again, you have to be a partner. And there's a session on licensing, but it's important to note that because you're using the infrastructure in a revenue generating application, have to be a partner. Okay, sharing the service. So here, instead of giving the user credentials, you're taking advantage of ArcGIS Online's inherent multi-tenancy. So what you do is you take data from your infrastructure, you ETL it into ArcGIS Online, you share that data into a group, and then invite the relevant ArcGIS users to the groups. So let's say you have a layer for customer A, you could create a group for customer A, invite the ArcGIS Online users from customer A, and then then create the data set online and share it to them through group A. In this case, you completely own the layer. You're just sharing it out to them. So you as the developer control the access and the administration of that layer. In this case, you also pay for the service because you're hosting it in your online instance. And then this mechanism works with any hosted service in online, but it also works with registered services in online. So that pattern before, you can actually register a service in your own online instance and then share that out via a group. So this pattern, again, only applies for partners because you're using some of the infrastructure in a revenue generating product. Or sorry, if you're generating revenue from this pattern, then you need to be a partner, is a better way to phrase it. A couple really important tips for groups. I know I at least when I first started creating groups, I was wondering what all these settings meant. So tip number one, keep them private and limit possible user interactions. Basically, you want to have your groups as locked down as possible. So people that should be able to view the group, only group members. You don't want the public to be able to see that your organization has another organization as a customer that you're sharing data to them, right? Who can contribute content to the group? Generally only yourself, and items group members can update only their own items, etc. So really try and lock these down. And the last tip I would add is give searchable names and tags so that the groups are easily discoverable. If you're using partner user types, or another way to phrase it would be if you're a developer and you're managing the users of your application, then you can lock down the group even further and prevent the users from leaving the group. That way you're guaranteed to know that the users of your application are in the groups that you shared the data to. Last schematic for one of the patterns is to publish the service directly. So here, instead of sharing the data out, you're actually using user credentials to directly write your data set into their ArcGIS Online environment or ArcGIS Enterprise environment. So in this case, once that data set's been ETL'd in, then the user controls access and administrative privileges to that data. They also pay for the service because they become the one that's hosting the data, and this works for any service that's supported by the user infrastructure. So it could be a feature service, but it could also be an image service because you're writing that into their environment. And so if they have the appropriate software and GIS in place, then you can write that data in. Cool. Again, enough slides for a little bit. Let's take a look at some demos and talk about sharing services, sharing versus publishing directly. So we'll go to a new notebook, and here I'm again going to log in with my MPason startups account where I have that template item. So let's just go grab that template item ID from earlier, copy it in, and so in this first section we're going to share an item via group. So first, what we'll do is we'll create an empty item just like before, and this time name it Shared EPC 2020 Demo Inspections, so we can differentiate from all the other services that we've been creating. And then once this is created, we'll also create a group. So we'll run this. And here we see the demo name. We have some descriptive tags, very great description. Again, access is private, so other people can't see that this exists unless they're invited. You have to be invited to join the group, and users can't update items unless they own them. So here we create the group, and then the important part is that I invite Spatial Startups, which is another account that I have access to, into the group, so Spatial Startups will be able to view all the data shared with the group. And this last line then shares that empty layer item to Spatial Startups through the group. So let's go check out that Spatial Startups account. Here I am, Spatial Startups. I can see that I've been invited to join EPC 2020 demo group. We can see that I've also run this demo before. So I have an invitation to join this EPC 2020 demo group, which I'll accept. And now Spatial Startups has access to a new group, which I can access, and voila, see that shared EPC 2020 demo inspection item, which still has my very descriptive summaries. So that's option one. Here I am sharing the data to the group. It's still owned by my administrative account, MPace Startups, but it's been shared to a completely different user in a completely different ArcGIS Online environment. Okay, second option is to publish the service directly. And before, that gave away some of the excitement, but before, the way that we would authenticate into the GIS was by specifying a username and a password. But in some cases this doesn't work because you want to, you might not know your end user's username and password. You actually just want to use a previously authenticated session to act on their behalf. So luckily you can do that by passing in a token. So to show how this works, here I have a demo app from the authentication authorization section that I know will display a token. So I'm going to log in with my Spatial Startups account. And when I log in, this application shows that I've completed the login process and I now have this token. So let's grab it and enter it in. Cool. Otherwise, the process looks very similar to before. So we create the empty service, but this time the GIS that's being created in is this one that is constructed with a token. So let's run it and see what happens. Oh, I guess I did make one subtle change in this section. Here I'm copying the data. I'm not, oops. An error occurred. Let's try it one more time. So yeah, in this case, I'm trying to copy the data because I think just to show a different workflow, essentially. So before I was creating an empty service. In this case, it's not actually empty. It's copying in the full data set from Spatial Startups or from mpayson_startups. This time it's taking a bit longer, so I'm hopeful that it's working, especially because it would probably take about this long to copy the data over. So we'll give it another hot second as it goes, and nice, it's done. Let's go check it out. So now I'm Spatial Startups. I'll go check out my content and see that there's now this new EPC demos folder. When I click it, I see these restaurant inspections. When I open it up, I see the descriptive summaries, I see the tags, and this time it's a item that I mSpatial Startups own, not mpaston_startups where the template came from. Cool. So I think that's pretty exciting. It shows basically two different ways to share services with end users. One, sharing it, and then the other one, publishing it directly. Next and final section, accessing existing services. So we've talked about how to create a service. We've talked about how to give users access to that service. But how do you as a developer then take advantage of that service in your application? So the challenges here are, how do you find the data specific to your application that you want to use that might be within the GIS? How do you discover what data users have available? And then another one that comes up pretty frequently, but fortunately not going to spend too much time talking about, is how do you standardize data models? So your application is a specific way it expects to work, but users might have different data models, especially if you're connecting into an end user GIS system. So there are really two options here. One is to store item info in your own user store, and the second is to use a pretty robust query API to search for items that the user can access. And we'll talk about each of these. So storing item info, what does the schematic look like? Basically, in this case, when you ETL the data over, or even when you create a new service that you share out, once that process is complete, you store the returned item results in a database associated with the user. So here, for example, you know the user because you have their credentials, and so you can, in your database, store the item results in it with the user information from the credentials. Then when the user goes to log in to your system, you also know who the user is, so your application can request back to your backend to get the appropriate item information, forward it on to the front end, and then start rendering and interacting with those services in the app. So this can be a pretty good workflow. Really the important note here is that it requires a backend system and integrated authorization authentication. So you need to have a server and database in place to store those item results, and then you probably also need to protect it so that not anyone can access those configurations. The second option is to search for items, and this is the one that we'll demo a bit more in depth. So in this case, let's say that you have a end user, you know they maintain data in ArcGIS. How do you discover what that data is? Well, again, you can have that user log into your application with their accounts. That will give you credentials scoped to their account, which you can then use to query the data that user has access to. And since the credentials that you're using for the query are specific to the user, you'll only see the results that are specific to that user as well. And from that, you can then build out a UI to select the items that the user might find relevant to the workflow, or to map to a schema. This is how things work in ArcGIS Hub, for example. So in ArcGIS Hub, you want to create an initiative that shows progress towards the Vision Zero initiative, where the end user might maintain a crash rate layer for car accident rate layer in their GIS. And the Hub initiative template to display that data in the Vision Zero initiative has a specific schema. So what Hub does is it allows you to interrogate the data that they maintain in GIS using that search API, and the user selects, this is my crash layer, and then these are the fields that are relevant to the template, and then Hub stores that as a configuration. So there's some UI development there, but basically as a developer, you can follow that same process. Now, if you're the one creating the data and you want to take this approach of searching for items, what you can do is you can use identifiable tags when you create the services so that you explicitly search for those tags in your application. Those can be, not necessarily tags, but you can also have identifiable metadata. So when you create the service, you have an identifiable title or you have identifiable tags, and you search for that and then pull it into your application. Cool. So let's talk a little bit in depth about the search API. We'll close out this for now. So here's the search API. It's very robust in terms of what it can do. At a high level, you can search for data based on a geographic bounding box, categories, category filters, and then other fields for sorting and pagination. There are also advanced query search options. So if we check out what these are, these include things by searching by title, by tag, by description, by type keywords, ID, title, and so on and so forth. And then there's traditional operators that you can use to tack different query parameters together. So this provides sort of a robust API endpoint that you can use to discover data that your users have access to. So let's take a look at how this works. Here's another demo that we created for the product section, and the use case here is we want users to be able to automatically enrich some of their data with a backend enrichment service. And so we want to let users select which data they want to enrich. So what we do is we display the layers and maps that they have access to, and also allow them to search for these as well. So search 50 largest, and I can see 50 largest. The way this works in the code is I wrote a search portal function in the map service that basically defines a query with some hard-coded parameters and then executes that query. So a couple things about this. One, the search query builder function is as a utility method within ArcGIS REST.js, an open source lightweight wrapper around the REST API, and it just provides a nice developer mechanic for constructing search queries, but you don't need to use it. But I used it here, and so we can see the kinds of parameters I'm defining. So the query looks for items where the currently signed in user is the owner, and that's a web map or a feature service, and then that matches the search string that is passed in from the UI. So show what that little query builder actually ends up adding. We can see when we update the query, here's the actual network request that goes out. So there's a query string that I constructed with the builder, and it makes that request. And here's the token that's scoped to the currently signed in user. To show you how this can change, let's now actually sign in with a different account. So let's sign in now instead with Spatial Startups. This is that account where we showed how to share services with it. So this is the one that has a copy of the template that Spatial Startups owns, as well as an item that was shared with the group. So when we sign in, we can see that there are now different layers that display because it's scoped to the user that's currently signed in. And we can even update this query to be specific to the items that we just created through the Python API snippet. So we can say match EPC 2020 in tags. If you remember, we added the EPC 2020 tag way back when we first published the CSV, and that propagated through all the different derivative or cloned items that we created. And then we'll say and, save it, go back to the app, and now we'll see just that one New York City restaurant inspection layer show up. And when I click on it, we'll hop over, and we see that it completely respects the settings that we defined way back in the first demo. It shows the pattern with the grade, it shows the clustering, and if you remember when I said there was one use case where I copied the item over and decided to clone the data instead of saying copy data equals false. I did that because I wanted to make a nice little map at the end. So here we have our little workflow, and we use the query API to allow users to select data that they have access to. So with that, let's wrap it up. So I hope that session gave you some helpful tips and tricks as you look to create services and feature layers and make them available to users of your applications. If you're interested in the source code, it's all on GitHub in all of its ugly glory. This is also our first time creating this presentation, so unfortunately, while we couldn't be with you in person, we would still absolutely love to hear from you, whether you have questions or feedback about the session. So please feel free to reach out to us. My email address is mpayson@esri.com, and otherwise, stay healthy and hope you enjoy the rest of your day.